excited to have you in here in our session. As far as our time here is concerned, I do want to make sure we get the most possible out of our time, and of course that you get the best experience for the amount of effort that we're putting in. Perfect. Now, as far as the session goes, there are a couple things that we are going to cover in this free evening. One of which, of course, is just to make sure that we're all on the same page. I've been teaching here for 12 years now. I started in 2005, actually teaching the MCAT. I love teaching the MCAT, and it really just gives me a chance to see a lot of students that are really putting in the effort, putting forth the motivated drive towards becoming physicians, doing amazing things with their lives, and I get to be kind of part of that experience. So this is my chance to sort of welcome us, welcome an intro. I've been teaching for over a decade, but it's not just me up in here helping you out. If you haven't already noticed, down there in the chat, we have a bunch of other phenomenal MCAT instructors. If you haven't already had a chance to chat with them, please reach out to us in that chat. I saw people logging in from all over the place. I saw Denver Nursing, I saw WVU, I saw Stetson University down there in Florida, some Worcester, Mass. Welcome, welcome. Again, this is obviously totally live. This is not recorded. I'm taking all of your input, I'm taking your feedback, and what I want to do today is, of course, as you know, as you signed up for, I am going to turn this over in about 10 minutes to one of my phenomenal colleagues. We've worked together for years and years. She's amazing. You're going to love it. We're going to go through one of my favorite sessions, which is kidneys. So much stuff that comes up on the MCAT that relates back to these systems. But before we get into any of that, I just want to make sure that we all know sort of where we're at in terms of studying and what you can do to get the most out of today's session. That's really my goal. I've been teaching for too long. At this point, there are a lot of tricks, a lot of shortcuts, but there's also a lot of just good, honest guidance that I can give. So I am going to turn it over to my colleague in about 10 minutes. But then afterwards, if you want to stick around for an extra half hour, 45 minutes, talk about MCAT prep, talk about options, talk about planning, talk about what to do for practice tests or exactly how many hours to study, I am willing to break that down granularly for everything that I have told students for the past decade and give you that same feedback. So please, of course, enjoy the session that we're about to jump over to, but that's sort of the game plan here, is to give you as much as possible in this free event so you can start making some good educated decisions on what you need to do from this point moving forward. And actually, that's a nice little segue into some data that we pulled at the very beginning. It looks like about 2/3 of everybody in this group so far are planning on applying this cycle and testing within the next couple months, about half of us. So if you are planning on testing soon, if you are planning on applying right away in this cycle, obviously there's a lot of good feedback that we can give, but also, again, reach out down there in that chat, have a chance to do a little bit of one-on-one conversation with some of our other off-camera instructors. Anybody here can give you that same sort of good one-on-one guidance, but I'm going to come back in, of course, and give you a whole bunch of it en masse after our content session. One thing I will say, though, before we jump over into that, is thinking about applying, thinking about testing really brings up these last couple of points that I'm going to hit at the end. What to do to prep between now and then. So I just want to put it out there as a blanket statement. I do not just sell classes. I'm a teacher. So if you want to take a class, that's awesome. I'll tell you the differences between the classes. I'll give you some feedback. But my goal here is to give you honest, good recommendations based on the time you have. So you're not wasting your time or wasting your money on something you don't need. For example, I saw about 1/3 of our group testing within this next month. You just don't have time to take a course. I would never try and sell you on a course or try and tell you to take one if you don't have time to do it. Those of you who are 3 months out or 4 months out and testing in the fall, sure, we can talk about that. But there are other recommendations I would make if you're taking the test in 2 or 3 weeks. Again, we'll talk about those at the end, but I wanted to put that out there as a blanket statement that you can reach out to any of our off-camera teachers. You can reach out and send questions to me privately, but I want to respect the time you're putting in here in your evening and respect the time that you're going to put in the future towards acing this test. All right. And I did see Edinburgh at 1 a.m. Welcome. Welcome, Amelia. This is one of the beautiful things about teaching online that I love is we get people from all over the place. I had a set of students in one of the classes I was just teaching who logged in on their vacation in Hawaii, and another set of that same students were logged in Turkey, the complete opposite side, complete opposite amount of time zone change. So this is just a beautiful thing. Now, as far as what we're here for today, of course, we are here for the MCAT. But what a lot of people don't really think about is that the MCAT is not really an obstacle to you getting into medical school. Unfortunately, a lot of people think of it as an obstacle or think of it as something getting in the way. I always think about it as an opportunity area. The MCAT is your opportunity to prove to med schools that they should take you. And that's really the whole idea of AAMC, staying in business for all of these years. Anybody who's in the bottom half of test takers for the MCAT, AAMC basically says, hey, med schools who are subscribing to our service, who are using these scores, don't take those. Those are the bottom half of students. You don't want them. No matter how much they would love to become physicians, they're not worth your time to train. Versus everybody in that top half, okay, these are maybes, but as you know, really the top quarter is what most med schools are really looking for. They're looking for that 510, 512 range and up, who are really proving that, hey, under a time crunch with a whole bunch of disparate content knowledge all at once, essentially summing up 2 years of undergrad, you're a person who can perform. You're a person who can prep for that and rock it. So this is our goal here, is to figure out how to do that and how to really take advantage of what you're seeing up here on screen. This is no joke. This is actually surveyed admissions officers from medical schools that we went out and actually polled, and they said, essentially as an aggregate, half or more believe that the MCAT score is the #1 most important factor in the admissions process. Again, this is not per se saying that the MCAT is an obstacle that we have to overcome. It's that the MCAT is an opportunity, a step up. If we can rock this test, we're essentially guaranteeing that we get our application seriously considered, that we get that next step, that we get to those secondaries, we get to prove ourselves with interviews. So changing our mindset is really a big part of this, I think. That growth mindset, that positive grit reinforcement can actually overcome a GPA that lagged a little bit one semester, or can overcome that you haven't spent every single summer doing clinical work experience, acting as a scribe in a third world country. It can give you that extra leg up, that extra boost in your application for what? A couple months worth of studying? For a little bit of money investment in some good resources and some good practice so that you can guarantee you kill this test? Absolutely. 100% that is worth it every time. You're going to spend more on applications and interviews and going to schools by far than you are going to spend on anything you could do for prep leading up to this exam. So totally, as far as that mindset, this is our change, that grit mindset, that focused endurance. Now, as far as the actual MCAT, again, depending on how much work you have done leading up to this test, there's a little bit of misconception sometimes about what's on the different sections. So I did like a couple great comments that came down through here in chat. Before we jump in with it, I really like Anthony's comment. Yeah, it is sort of like that kidney stone we have to get past. It's not an obstacle per se, right? It is this thing that we just have to get rid of before everything else can flow, if you will, smoothly towards us becoming physicians. Now, as far as what's on screen right now, obviously, we want to break down a couple main misconceptions here. So sure, the timing breakdown and the question breakdown is exactly what you see here on screen, and that's what AAMC promotes on their website. You can read up about it if you go to aamc.org/MCAT. However, one thing that a lot of people freak out about, and it's because generally for undergrad pre-health programs, there's not a lot of time spent doing psych-soc. A lot of people freak out about that section and think, well, this is something that I'm going to have to take a couple classes in, maybe over the summer. Let me let you in on a couple things. First of all, there is psychology and sociology in there. Totally, you do have to do some flashcards, buckle down, and spend likely about 100 hours or so, about an hour a day for about 3 months. That's about 100 hours, going through psychology, sociology, memorizing flashcards, doing practice problems, and really getting up to speed on the content you may be missing. But one of the nice things about it is, for example, with the MCAT books, all of that is built into the resources and books and review notes you would get up front. So you can kind of focus in your strategy, focus in your efficiency, and not waste time, going on Wikipedia or browsing YouTube trying to find videos. The other thing is, notice it says biological foundations of behavior. I love this because actually the stuff that my phenomenal colleague Justine is going to be teaching in our session coming up in about 5 minutes about kidneys, or even a session about neuroanatomy, or a session about digestive system, could potentially come up in the psych-soc section. I'll give you a bonus question right now for everybody. It's not related to kidney, but it's just kind of a fun question. And hit me up down here in the chat if you think you know the answer. This was a question I legitimately saw on the test. It went like this. And this is in the psych-soc section. A patient is suffering a neurological disorder that causes insomnia-like symptoms when they are exposed to excessive amounts of blue light. Which part of the brain is most likely directly responsible for this behavior? Now, again, I'll wait for some answers down here in chat if you think you know. But notice that this is what seems like, psychological disorder, something about insomnia-like symptoms. I have to memorize this? No, we didn't. As Dominica put down here in chat, blue light neuroanatomy. Blue light neuroanatomy, that's all the MCAT needs to give you for a clue that this is specifically pineal gland. Yeah, and I love that Kendall and Kamal and a few others put in here occipital lobe, because of course we're processing that information. But right off the bat, boom, one link. If they had added in one more piece, it would have sealed the deal for us. Forebrain structure, boom, it would have been pineal, no question. Now, often I have a lot of students get confused between that and pons. Right, pons is a hindbrain structure, so they'd have to give you the additional clue. And that's sort of the magic of studying for the MCAT. I saw so many answers down here in chat that in general, if this was a midterm or if this was a final, they'd be looking for multiple answers or a larger subset of the system. But because this is the MCAT, they clue you in with very specific points, and they want you to match to it. For example, if you've done some advanced neuroanatomy classes, maybe junior, maybe senior year, you know that there are multiple parts of the brain that are responsible for emotional responses or anger responses or fear responses. But if the MCAT ever said fear or anger, boom, that's a neuroanatomy match to amygdala. That's it. Sure, there might be some other ones that are tangentially involved, but that's not what the MCAT's getting at. And actually what I'm getting at here is another unfortunately misconception that in the biological sciences or in the chemical sciences you have to go back to all the stuff you studied before and get your second year and your third year content. But often the MCAT actually rolls it back to fundamentals and basics, and you may know too much in biology at this point. You may know too much about anatomy and physiology, and you may be kind of zeroing in on, unfortunately, a too specific trap when what they were hinting at was a broader application question. Now, with that kind of analysis here, with that concept of what is the MCAT expecting you to get at, what is the MCAT expecting you to kind of pay attention to, I actually want to directly hit up this slide. This guy shows exactly what I was mentioning a second ago. Here's bio, that dark blue. Notice that we've got about a sixth or so, or a little bit higher sometimes, up to about 20%, that is essentially pure bio questions in psych-soc. Sure, the rest is split between psychology and sociology, but it's biological foundations of psych-soc. Similarly, even in the bio-sci where everybody's freaking out about organic chemistry is only this little tiny nub within biological and biochem foundations. This is something that has changed a lot over the years. So if you've been talking to somebody who's currently in med school who took it back when orgo was a third to a half of the test, no, the test has gotten actually nicer to us. So I'm psyched about this, and I'm psyched to give you some recommendations I have about the different breakdowns. But again, everything up here on screen, this is really all taken straight from AAMC's website. This is all the breakdown you can find elsewhere. But if you've got more questions about it, if you've got more concerns about the exact distribution or want some extra pointers I've got, I'm happy to answer those down here in chat. I'm happy to kind of sidebar at the very end and take some extra time. But an additional question I just saw privately come through, awesome question, was what about Chem Phys? Yeah, you may have noticed this. Nice question. Again, you can submit questions privately and we'll answer those privately too. This is a good one. I'm pulling it out for everybody. Notice in Chem Phys, we have about a quarter of all the questions are essentially bio questions. So they'd ask you something about the angle of flexion of the knee and then essentially rolling it back to a tendon question or something about the knee essentially being a musculature system question where it's all bio in the background. I love this. This is, again, just kind of fine-tuning it more towards what you're going to need as a physician, as opposed to just brute memorization of formulas. So at this point, I do want to just transition at this juncture into that final segue of, if we're talking about content, if we're looking at this crossover between sections, then we need to do a little bit more than just science knowledge. Yes, you have to do foundations. Yes, you have to study. But absolutely, we have to do a little bit more than just studying and just going back over Wikipedia and just going over those old textbooks. We have to have some problem-solving skills. We have to deal a little bit with experimental research. We have to analyze data, at least data that comes up in a chart or a graph or a table. And we also have to have this one last thing. If you attended our free practice test yesterday or the other ones we've got coming up over the next week or two, the free practice test often shocks a lot of people who come into it cold because they think, hey, I got an A in both of my undergrad first and second year bio classes. I got an A in Gen Chem. I took the physics one without the lab or with the lab. I did pretty good on it. I feel strongly on it. I'll just walk into this test as far as a practice test is concerned. But they get shocked by the fact that this test is not just those things on the right-hand side. This test is also figuring out those clues for the MCAT. So when you see blue light and forebrain, you think melatonin, you think pineal gland. When you see fear, anger, you don't think about all the other things that could potentially be involved, and anger could certainly be some sort of hypothalamus response if we're in a fight or flight. But no, fear, anger on the MCAT is a direct clue to amygdala. Okay, great. Once we learn all of those kind of translation clues, we can actually make this test not just solvable, but handily answerable. Putting time in upfront, even if it takes several months to do it, means we put in the effort, put in the grit, use that resolution to motivate ourselves towards walking in on test day and breezing through this test and hitting that top 25 percentile or better to really show schools we are physician material. We are the kind of stuff that they want. So speaking of actually putting in that time and doing that work, we are exactly here, right on time for me to transition to my phenomenal colleague. Justine is going to lead you through from this point forward, giving you that kidney session that we've been waiting for, and immediately afterwards, she'll transition back to me and we'll talk about some of those guidance tips and kind of just general good test prep recommendations I have. Take it away, Justine.
All right, guys. So I am super excited to get to talk to you all about the kidney. The kidney is definitely a very high yield topic on the MCAT. And I think one of my favorite comments I saw coming into chat was the don't hate urinate from Cameron. So that's exactly how we are going to approach the kidney, which is a perfect way to think about it, since that's one of the important functions of the kidney. So as we go through our review of kidney physiology, we're going to focus on two main aspects. We're going to look at the main functions of the kidney and also look at how the physiology of the nephron allows it to perform that particular function. And for those of you who are just starting your review of anatomy and physiology, which is pretty high yield, you do need to know about the human body to be a doctor. One of the most important pieces of advice that I can give you is when you study anatomy and physiology, you really want to focus on the structure-function relationship. What about that specific organ, whether it be specific cell makeup, different enzymes that it produces, different proteins that it contains, allow it to perform its specific function? And that's really what we're going to dig into in our lesson here today. So we're going to start with just the main functions of the kidney. And I know that most of us, when we think about kidney, we just say it's what makes urine. But what are some other functions of the kidney that we may not immediately think of? Go ahead and tell me below there in the chat. What else does our kidney do? We know, yeah, Cameron, we got the glomerulus. Yeah, Holly, we have the golden liquid. So we know that it is certainly involved in excretion. Of course, that is the creation of urine, a way to eliminate waste products from the body. Part of that also allows us to regulate the components of the blood. And when we think about components of blood, we're looking at the osmolarity, the pH, the salt component. Yeah, Shandy, we have the renin-angiotensin system. Oh, Lizzie, yes, secretes EPO, absolutely. So when we go through and think about these, of course, we're going to focus a lot on the plasma osmolarity, the pH, and the blood volume, because that's what the MCAT loves to test us on. We also want to think about how we measure concentrations in the blood. And we do that with osmolarity. So when we say an osmol, that's just a measurement of everything that is in the blood, the total concentration of all dissolved species. And our blood should be around 300 milliosmol. And that is absolutely a value that you should know for testing. But getting into those other functions, I saw EPO come in. Of course, many of us know about EPO if you follow like the Tour de France or other sporting events. EPO is a hormone that is definitely abused by a lot of athletes. And one thing I will really push for this is if you ever forget what something does, look at the word roots. So if we look at erythropoietin, what is its specific function in the body? What does erythropoietin do? Why would our athletes love abusing that specific hormone? Yeah, Shani, you got it. Red blood cells. Yeah, Jessica, Alex, perfect. And yeah, so I like that. Something with blood. Something with blood cells. You see that erythro indicating that it has to do with red blood cells, and poietin is what we commonly see for go make more of. So erythropoietin is what stimulates red blood cell production in the bone marrow. We also have calcitriol, has something to do with calcium. This is what allows us to absorb calcium from the GI tract. It also is involved in gluconeogenesis. It tends to take a secondary role in gluconeogenesis because the main star of making sugars is the liver. The kidney also is able to do so. So, of course, since we're going to talk about everything going on in the blood, we do want to talk about what is in the blood. And we have several different fluids in our bodies. We have the intracellular fluid. This is, of course, just inside our cells. And we have the extracellular fluid, which would be outside the cells. It's the fluid that bathes the cells. And I will tell you, you should know these differences in concentration. And if you're like me, you hate memorizing things, what I like to focus on is why does it make sense that it is set up in this specific manner? So if we look at sodium and potassium, how many of you are starting to think about the sodium-potassium pump? That's how I like to remember this one, the sodium-potassium pump. Remember sodium-potassium pump. Of course, it will be pumping sodium out and pumping potassium in. So in order to want to pump things against their concentration gradients, it would make sense that sodium has to be high outside. That's why we pump it out. And potassium has to be high inside. And that's why we need active transport to pump it back in. When we look at calcium and chloride, I like to think about neurons. Calcium is needed for neurotransmitter release. We have voltage-gated calcium channels at the ends of our axons that are axon termini, and the opening of these calcium channels is what allows us to release that neurotransmitter. So it has to want to flow into the cell, so it has to be high outside. Same thing with chlorine. What effect would chlorine have on a neuron? Would we expect that to be activated by an inhibitory or an excitatory neurotransmitter? Let me think. If we have chlorine entering the cell, is that going to be due to an inhibitory or activating neurotransmitter? Be a little connection to some psych soc here. Should know your neurotransmitters. Exactly, Lizzie. Yeah, Karen. It's going to be inhibitory. Absolutely. Allows us to hyperpolarize our membrane. So again, in order to have these ligand-gated channels, we need to have it spontaneously flow in, so it has to be high outside. With phosphate, very important for DNA, want it to be high inside. Bicarb, that's the blood buffering system, so that'll be outside the cells. Albumin, really important for carrying different lipids, specifically often used to carry steroid hormones around the body. And proteins, we're making them in the cells, they're going to stay in the cells. So instead of just memorizing specific pieces of information, it can be very useful to relate it to other pieces of biology that you know, and that will help you to decrease that cognitive load. And that's really how I like to study biology. You don't study it in like an isolated system. Biology is the entire organism. So focus on making those connections with content as you review material for your MCAT. So let's look at how this fluid balance works in the rest of the body. So we have three different fluids here, like we've already mentioned our intracellular fluid. We have also mentioned our interstitial fluid. That's essentially, you can think of that as the extracellular fluid. And then we have our plasma, our aqueous component of our blood. And I did see a really good question here from Cameron. Does the sodium potassium pump use 1 ATP per cycle? Yes, so it is 3 sodiums out, 2 potassiums in per ATP hydrolyzed. And that's a very high yield pump in the body. So make sure you have that one down. You can see it in as how cells regulate their volume, and also plays an integral role in transmission of action potentials. So great question. So we have that sodium potassium pump back here. Your body actually expends a significant amount of energy just running that pump. So we'll be able to establish the concentration gradient across the cell membrane. The capillary membranes, on the other hand, are a bit leakier. So the composition of the interstitial fluid is going to be really similar to the plasma, and that's because you have little pores that allow small molecules to pass through. So these tend to be a bit leakier. However, those little pores are not large enough to allow protein to pass through. So we'll have a high concentration of albumin in the plasma, but it will be very low in the interstitial fluid. Very low in our interstitial fluid. There is one last part that connects the plasma and the interstitial fluid. It serves as a means of bringing excess fluid from the interstitial fluid back into the plasma. What system is that? We typically associate that a lot more with the immune system, but blockages of this system can lead to edema, where you have a buildup of fluid in the extracellular fluid. It's what causes lymphedema, where you have large swellings of the limbs. I might have given it away with lymphedema. So it is the lymphatic system, exactly, Chiamaka, that links, you got it, Kamal, Alex, that links the interstitial fluid and the plasma. So important for fluid regulation and balance in the body, but typically its claim to fame is in immunity. It's what the lymph nodes are for, surveilling everything that is passing through your body. And our concentrations of everything, our milliosmolarity of every single fluid will be 300 milliosmol, and that's because water is able to pass through all of these membranes, both the capillary membranes and the cell membranes. You have those little aquaporins or water pores where water is able to move. So now let's take a look at a practice question here. So I want you to take some time to think about this one on your own. And I also want you to, we'll get a poll up for you to poll into. And I'm going to give you just a couple seconds to read through this and tell me what you think about this one. This is a really great MCAT question. So it starts by giving us the definition of albumin, the major blood osmoregulatory protein. This is something you will know already by test day. And we have a sharp rise in serum albumin. We have a sharp rise. Now let me see where we are in this poll. So we're a little bit split. We have some of us going for A and B. We have main split, it seems to be between A and D. So let's reason through this. So one thing that sometimes I like to do when I have questions is just to draw out what I know. So we have our blood, we have our plasma, and then we have the interstitial fluid. Just put ISF for interstitial fluid. I always say a picture is worth 1,000 words. And we are told that we have a sharp rise in serum albumin. So we have more protein in this location. Now, if we think back to just osmosis in general, water is always going to follow stuff. Water is the groupie for stuff. So if I start to add more stuff into my plasma, I'm going to see the movement of fluid from the interstitial fluid back into the bloodstream, so I can get back to an osmolarity of 300 milliosmol. So here we would want to go with answer choice D. And if you missed this one, that's totally fine. Don't ever feel bad about mistakes that you make in practice, because every mistake that you make as you're practicing is really a learning experience. And I can tell you from personal experience, I made so many mistakes on practice questions when I was prepping for my MCAT, and that's really more memorable than getting something right. I can tell you I took 3D calculus like 10 years ago now, can't remember anything that I learned in that class, except for if you gave me the same problem I missed on my final, I'd be able to get it right to this day. So own up to the questions that you miss, because that is really going to help you to learn. Yeah, yeah, like what Mike's saying, if you don't make mistakes, you're not trying. You don't learn anything by getting stuff right. You learn from getting stuff wrong. That's the mindset you want to get into as you prep for your test. But now let's move into more of that physiology of the nephron, looking at that structure-function relationship. So if we think back to just what the kidney does for making urine, well, first of all, I know a lot of you were telling me that the kidney filters the blood. So between your two kidneys, you filter about 180 liters of blood every single day. That's a lot of fluid that we're filtering. So if we're filtering that much fluid, what must we be doing with water? I don't know about you. I have never had a day where I peed out 180 liters. So if we are filtering that much blood, what can we say about the amount of water that we are reabsorbing? Yeah, Lizzie, reabsorbing, and we're reabsorbing a lot of it. You got it, Holly. Most of the water that we filter, we will reabsorb. So that's another function of our kidney. It's the reabsorption of both water and nutrients. Essentially, when I think about reabsorption, I think keep the good stuff. Keep the good stuff. Certainly that's water. Without the ability to reabsorb water, you would urinate to death in a matter of hours. So we can all say, hashtag thanks kidneys. We also need to get junk out of the body, and we do that through secretion. Now, there's a lot of things that we do secrete, but what does urine actually get its name from? Why did we name urine urine? We'll talk about all the stuff that we secrete, but there is one that really is a main component, and that's urea. You got it, Holly, Kamal, Francis, yeah, Karen. Urea, it's a product of protein metabolism. It's a way to get rid of nitrogenous waste. So potassium and protons are in there, but one of the main components is urine. So once we take this all together, what we excrete, what we urinate out, will be what enters the nephron minus what we reabsorb, because it's not going to get lost, plus what we secrete. So we'll be producing urine in our kidneys. Then we go to the ureter, bladder, and out the urethra. So let's take a look at our nephron. Let's take a look at our nephron. So this is certainly a simplified diagram of our nephron compared to what we saw on the previous slide here. It's going to be a little bit easier to look at our, I guess, cartoonified version. But of course, as we know, these proximal convoluted tubules will be quite squiggly. We're just getting a little bit easier to work with diagram here. And we'll go through each of the steps: filtration, secretion, and reabsorption in good time. So the first part will be filtration. That will occur at the glomerulus and Bowman's capsule. We'll get stuff into our nephron. As we secrete, we'll be adding stuff from the blood to the nephron. And when we reabsorb, we'll be taking stuff back out. Now, one last thing I really want to point out on this diagram, and this is something we'll come back to at the very end of our kidney session, is this increasing ionic gradient in our interstitial fluid. This is one of the main drivers of water reabsorption. This is what the loop of Henle, this little loop here, establishes the countercurrent multiplier system. It was actually a system that when they first proposed it, people said, oh no, that can't be right because it was very complicated, but we're totally going to break it down. It's actually really fascinating how it works, which is why the kidney is actually my favorite organ of all time. So let's start with filtration. So filtration happens at the glomerulus and Bowman's capsule. We have a few capillaries coming in. So I know whenever I was studying for my MCAT, I always hated the difference between afferent and efferent. So we have afferent and we have efferent. And I always remember efferent by E for exit. Now we have a few different pressures going on here, and the two that we really want to focus on are hydrostatic pressure and oncotic pressure. So first of all, hydrostatic pressure we can think of as a pressure caused by moving fluid. That's how I like to think about it. It's essentially a force applied from moving fluid. And what part of our body allows us to set up a pretty high hydrostatic pressure in the glomerulus, in our circulatory system? What gives us that high hydrostatic pressure in the circulatory system? And Levi, pressures are your kryptonite. That's okay. That's why we're going to break it down here. So we have, and this is saying the aorta. Think about a little bit closer to the central part of your circulatory system. It's going to be your heart. The heart is the driving force behind moving fluid through the circulatory system. So any part that is in the circulatory system will have higher hydrostatic pressure than fluid that is just sitting there. So it makes sense that the hydrostatic pressure in the glomerulus is going to be greater than the hydrostatic pressure in the Bowman's capsule. So here in the capillaries, we'll put high hydrostatic pressure. And in the Bowman's capsule, we'll have low hydrostatic pressure. And this makes sense. We've got the heart pumping, we're going to get some hydrostatic pressure from that. Fluid in the Bowman's capsule just kind of hanging out there, it's going to be fairly low. And this brings us to the oncotic pressures. So at this point, we want to think about things that we do and do not filter. So anytime I think about things that we don't filter, I like to think about things that we can see in the urine. Like if you had an issue with your glomerulus, you could look down in the toilet and say, oh my gosh, something is wrong. So I want you to think about that. What are the two things we can see being wrong with our urine? And while you think about that, Lizzie, you have a great question. What happens if hydrostatic pressure decreases in the capillaries? Well, that's actually an issue with people with congestive heart failure. So if your cardiac output gets too low, your rate of filtration will go down and you can get an accumulation of waste products in the body. That's why a large number of medications they give to heart failure patients actually act on the kidney. It's a way of getting fluid out of the body because they just don't have the blood pressure to drive that filtration. So nice clinical correlate there. Great question. But I'm seeing some answers coming in. Proteins you can see in your urine. That will be a cloudy or hazy urine, which will indicate either there's something wrong with your kidneys or you have an infection. The other one is blood. So blood and proteins. So we should not see protein in the urine, and that's because it's not filtered. So if we were to do like a little microscope view, if we were to just like zoom in right there and look at our capillaries, what we see are actually these little pores or fenestrations in our membrane. So things that are really small can pass right through. That would be like small ions, sugars, and vitamins. But if I have a protein, that protein has a little Gandalf moment. That little pore is like, puts out its staff and it says, you shall not pass. So let's think about what happens as a result of this. If I get an accumulation of protein on one side of my membrane, what's going to happen to its oncotic pressure? I get a buildup of protein on one side. What happens to our oncotic pressure? Giving Gandalf the weight. Yes, Amy, it's going to increase. Solid reference. So it's going to increase. So that's what gives us also a high oncotic pressure in the capillaries and a lower oncotic pressure in the Bowman's capsule. Now, if we think about the result of these pressures, a high hydrostatic pressure and a low hydrostatic pressure tells us that we want to be moving fluid from the glomerulus into the Bowman's capsule. So this pink arrow would tell us the direction fluid would move with that hydrostatic pressure difference. If I have high oncotic pressure, that's essentially pulling fluid back. So with the oncotic pressure, it would be telling us to move fluid back into the capillaries. But given that we have to generate urine, we have to drive filtration, which one of these two pressure differentials is going to be larger? And Anthony, oncotic pressure, you can think of it mainly as an osmotic pressure that's due to protein. So since we have more protein in the capillaries, since we can't filter protein, oncotic pressure has to be larger in the capillaries than it would be in the Bowman's capsule. So if we have to drive filtration, if we need to oh yeah, Megan, absolutely, I'll put it on there. So oncotic pressure is the pressure caused by a difference in protein concentration. This is very much so analogous to osmotic pressure. Has the same effect. If I have more protein somewhere, it's going to suck in more fluid. So if we want to keep stuff moving from the capillaries into the Bowman's capsule, that hydrostatic pressure difference must be driving the filtration. So the hydrostatic pressure difference is going to win. And we can see, I'll just populate, there is a equation I want to show you. This is exactly what we just discussed. The equation here is for our filtration rate. And this honestly, like if you look at this equation and say, you know what, that's really complicated. I don't know if I really like this. That's totally fine. Really what this entire thing tells us is that this hydrostatic pressure difference must be larger than the oncotic pressure difference in order to drive filtration. So it's the hydrostatic pressure difference, here I'll highlight that drives our filtration. And we're going to play a little game here, which is something the MCAT loves to do. And that game is, what if things go wrong? So we're going to take a look at a few different changes that we can make and think about qualitatively how that would change our filtration rate. So we're going to get a poll up here for you to poll into. And we're going to go through each one of these examples, whether it will increase or decrease our filtration rate. So our first part is asking about constricting the afferent arteriole. We're looking at constricting our afferent arteriole. So if we're constricting our afferent arteriole, what we're doing is we're narrowing it. We're narrowing it, making it harder to pass through. So if this now is a smaller opening, would we expect to see more or less blood flowing through? We are seeing the answers in that poll starting to change. I like it. If we are constricting, we're going to see less fluid, less flow going through this. And that's going to give us a decrease in hydrostatic pressure. Less hydrostatic pressure, remember that is what forces the blood, or not blood, but forces filtration. If that is lower, we would expect to see a decrease in the filtration rate. See a decrease in our filtration rate. Now let's have another part of this system broken. Now we're going to constrict the efferent arteriole. I'm going to constrict the efferent arteriole. Well, I like to think of this as kind of building a dam. If I constrict over here, I'm going to start to see, well, if you think about a dam, you always see a higher water level upstream. And that's exactly what we're going to see in the body. We're going to see an accumulation of fluid in our capillaries. So more fluid means more pressure. So this is going to cause hydrostatic pressure to increase. And I'm loving what I'm seeing in this poll. You guys are doing a stellar job here. We're going to see an increase in filtration. So wonderful work. We're going to do, I would say, the most painful exercise because it has a kidney stone. Kidney stones are incredibly painful. I know when I first thought of kidney stones, I thought like a smooth river rock. That is not the case. They're like spiky and horrible, and that's why people are in a significant amount of pain when they try to pass kidney stones. So if we have a kidney stone, that's essentially going to be blocking down here. So we'll have fluid moving into our Bowman's capsule, but it's going to start backing up. It's going to start backing up. So we're going to start to get more fluid in our glomerulus. More fluid means we're going to get a higher hydrostatic pressure. Higher hydrostatic pressure. So that difference in pressure between the glomerulus and the Bowman's capsule is going to get smaller. So if I have a smaller difference in hydrostatic pressure, what must happen to our filtration rate? Anthony, kidney stones are your #1 fear. That is a legit fear. And if you are worried about getting kidney stones, definitely reduce your soda intake because that can exacerbate a problem. So if we have this buildup of fluid in our glomerulus, that is going to get us a decrease in our filtration rate. So absolutely phenomenal work on these questions so far, team. I believe that we're in for a little bit of positive reinforcement to think about a little bit of psych-soc. I'm going to give you a little smiling star. So great work, team. Doing phenomenal work. Yeah, and really, Christina, protein shakes, honestly, if you are eating a healthy diet, you really are not going to be at a loss for protein. So we actually kind of discussed this a little bit earlier. What makes it into the filtrate? Remember, this is the stuff that we don't want to visually see in our urine. So we already said that cells and platelets should not be in there. If we had that, we'd see essentially bloody urine, which actually you can see if you've ever been punched in the kidney. Not a pleasant experience. We can see ions, but what about glucose? Is glucose going to make it into the filtrate? Remember, we're saying filtrate here, not urine. So do we filter glucose? Do we filter glucose? Is that going to make it into the filtrate? Yes, it does. So whatever your concentration of glucose is, it will be present in the filtrate. Now, I know that Lizzie is mentioning diabetes. Diabetes, people with diabetes will have glucose in their urine, but that's because their blood sugars are so high that it actually overwhelms the body's ability to reabsorb glucose in the nephron. So we do filter it. We just have means of reabsorbing it later. And fun fact, any of you who like to be disgusted by previous practices in medicine, before you had the little dipsticks for testing urine, the ways that physicians used to diagnose diabetes is by sweet tasting urine. So be glad that you are getting into modern medicine, because back in the day, you would actually have to drink the pee of your patients to determine whether or not they are diabetic, which is pretty disgusting. Fun facts. And we've already said protein will not make it into our urine. It does not pass through those little holes or fenestrations. You're parched. Yeah, there's like a whole scale that they actually had for just looking at pee. Yeah, what a great time to be a doctor. Exactly, Kamal. So let's take a look at secretion. Now, secretion is where we are adding stuff from the blood to the filtrate. So this is a way of eliminating wastes from the body. So what are some things we might want to get rid of? I'm actually going to show you a really cool mnemonic to remember these, but there's 4 main ones that we like to excrete. What kind of waste products do we not want to see in our body? We get rid of here. We can actually use this to regulate homeostasis as well. Nitrogenous waste, absolutely, Callie. Yeah, Mary, protons, perfect. Urea, you got it, Diamond. So here's the mnemonic. I don't know if any of you would notice this about me, but I'm totally a nerd. And when I got married, I married like another very, very nerdy individual. And before I was able to do that, I had to dump the hunk I was currently dating. So when you think about your components that you secrete, you always want to dump the hunk because you want to marry a nerd. So hunk, hydrogen, urea, nitrogen, potassium. So dump the hunk. Oh, and yeah, Holly, you would be getting, I don't know if you would be secreting specifically drug metabolites, because that's not something that you naturally have in your body. That would be something that would be eliminated from the body via just normal filtration. That's actually why if you drink a lot of diet soda, you may notice that you pee more with diet soda than you do with regular soda. That's because there's no way to reabsorb the artificial sweeteners So more stuff in the filtrate pulls out more water. So a little fun fact for anyone who has a tiny bladder and is looking for ways to pee less. If you're going to drink soda, drink the normal stuff. 10 out of 10 on the acronym. I like it, Athena. So we're going to dump our hunk. And we can also excrete stuff that is too large to be filtered. But do just remember, it has to be something that is naturally occurring in the body for us to have transport systems to do that excretion, because this is all mediated by transport proteins. We can also change the levels of secretion based on our body's needs. So if we are eating a lot of protein, we're going to see more ammonia and more urea secretion, since those are products of protein metabolisms. That is why a very high protein diet can be problematic for the kidneys. Also, if our blood starts to become too acidic, well, we can just start excreting protons. Now, what's another way that we can compensate for low blood pH? Because your kidneys can help with this, but this is actually something that your brain is involved with. Something that your brain is involved with. So it's not something you have to actively think about. Yeah, Jessica, it's bicarb. The lungs, we increase the respiration rate. So whenever, that's actually how we are able to regulate our respiration rate. It's actually not based on the concentration of oxygen. It's actually based on the concentration of carbon dioxide. Whenever we have a high concentration of carbon dioxide in the body, that will lower our blood pH because of the bicarbonate buffering system. And that lower pH is registered by the medulla oblongata in the brain, which triggers an increase in your respiration rate. So if we have a decrease in blood pH, we'll start, urinating out more protons, but we'll also have that increase in respiration rate. Oh, nice work there, team. Now, the last part we got to talk about is reabsorption. This is how we get the good stuff back into the body. So we're going to reabsorb a lot of different stuff. We're going to be reabsorbing salt and water. That's what allows us to not urinate out that 180 liters of fluid every day. We also need to reabsorb amino acids, glucose, and vitamins. And that's pretty much, for purposes of the MCAT, always going to be reabsorbed unless you have disease. And we'll talk about that in a little bit with diabetes. And your reabsorption of these nutrients will occur specifically at the proximal convoluted tubule. So that's where we absorb all of the good stuff. We'll continue to reabsorb water in the descending loop of Henle. I always remember we absorb water in the descending loop because water flows downhill. So water flows downhill. We reabsorb water in the descending limb of our loop of Henle. The ascending limb of the loop of Henle is not water permeable because water flows downhill, it does not flow uphill. So in that ascending limb here, we're really only reabsorbing salt. So when you're looking at loop of Henle, descending is water reabsorption. The ascending limb is salt reabsorption. So descending, water reabsorption, ascending, wow, that says salt, salt reabsorption. The distal convoluted tubule and collecting duct are the main site of two hormones that act on the kidney. So what are the two hormones that we use to regulate fluid balance. Got two different hormones. One of them reabsorbs water. Nice, Melissa, Mary, Evan. We got ADH coming here in the house. That's what acts on the collecting duct. So ADH increases the reabsorption of water. The collecting duct itself is normally not permeable to water. So what ADH does is it causes the fusion of aquaporins to the membranes of the collecting duct, and that gives us an increase in water reabsorption. So ADH acts at the collecting duct to increase water reabsorption. Yeah, like Mike is saying, always drilling holes. Yeah, and vasopressin is the same thing as ADH. You got it, Bex. And I saw aldosterone coming in as well. So aldosterone acts primarily at the distal convoluted tubule. And that will lead to an increase in salt reabsorption, increase in sodium reabsorption. And if I'm reabsorbing sodium, its groupie is going to be coming with it. We're going to reabsorb water as well. So ADH, we only reabsorb water. Aldosterone, we reabsorb salt, and then water follows. Water always follows salt. So let's look at a little critical thinking exercise with this. So we're going to take a look at what's going to happen if we make some changes to something that we are reabsorbing. So let's first start by defining our lines here. So we have this blue line. This is the filtered load. This is essentially the concentration in our blood, which when filtered will be about the concentration it is in the filtrate. We have our red line, which is what we reabsorb. And anything that we don't reabsorb has got to be secreted. So this kind of funny. It's the yellow line here. Someone has a nice sense of humor here. Anything that is on this yellow line is going to be what is excreted in the urine. So we are asked two questions here. How would this graph change if we either change the molecular weight or we change the TM? Now we're going to start with the molecular weight first. And I want you to think about how we filter. So remember, we have these pores in our membrane. We have these, we call them fenestrations. And I think one of my favorite words in the English language is the word defenestrate. Defenestrate literally means to throw out of a window. So I like to think about defenestrating our solutes through these fenestrations in the membrane. And I want you to think about how easily it would be to defenestrate something that has a larger molecular weight. Is it going to be easier or harder to throw something that is heavier out of a window? I've never tried this at home. I've never like thrown anything interesting out of a window, but you see a lot of it on like funny like shows and stuff. So what do you think? If I have something that is heavy, is that going to be easier or harder to defenestrate? It's going to be harder. Yeah, Tally, Kamal, you got it. And Diamond, we will talk about the TM in just a second. So if I increase my molecular weight, it's going to be harder to throw it out the window. So we would expect the filtration rate to go down. So our blue curve would be flatter. There's less that would be entering the filtrate. Now let's talk about our TM. The TM is a measure of the maximum rate of transport. You can think about this like a Vmax for a transporter. So Vmax we normally, ascribe to enzymes. TMs are Vmaxes for transport proteins. They're not catalyzing anything, but they're just moving stuff. So if I have a larger TM, if I have a larger Vmax of transport, what would we expect for the amount that we can reabsorb? So Ray Cameron, the Vmax is for enzymes. It's looking at a rate of catalysis. When we're looking at TMs, that is a maximum rate of transport. So it should increase, absolutely. And we have the definition of TM up here. It's the max rate of transport for a transporter. So we would expect that red line then to plateau at a higher rate. That also means that we won't excrete as much. So we can reabsorb more and secrete less. And one thing you might notice about this is actually looking at plasma glucose concentrations. So normal amounts are less than 100. So in normal individuals without diabetes, we're somewhere in this range. So we're able to reabsorb all of the glucose that is filtered. However, if we have diabetes, blood sugars can get really high, 2 to 400 can get quite high. So at this point, we start to see that we are overwhelming our transport, and we're going to start to get glucose excreted in the urine. So that's why we see glucose in the urine of diabetics, and that's why they also urinate a lot more, because more solute in the filtrate, remember, water follows stuff, will pull more water with it. Little clinical corollary there. Now, the last thing we have to look at here with our kidney is our counter-current multiplier system. So before we really just dig into it, I want to set up an analogy here. I want to set up an analogy, and then we'll talk about how this whole thing works. Say we're going to play a game, not like, the creepy games they play in the movies. We're going to play a little game here. And the game that we are going to play is we always want the ball to be in this square. And we have to run. And each person can only run in one direction. So if this guy gets the ball and starts running, he is not going to be able to keep the ball in that square. So if I put another guy on the field, do I want my guy running in the same direction or in an opposite direction than this guy? What do we think? If we want to keep the ball in that square, do we want to have a second player running in the same direction or in an opposite direction? This is really the basis of the countercurrent multiplier system. It has to be going in the opposite direction, absolutely. So we have to have things moving in opposite directions if we want to concentrate something in a specific area. And that is exactly what the countercurrent multiplier system does, albeit in a more complicated and more convoluted way. But I want you to be thinking about this little game as we analyze our countercurrent multiplier system. Unless the player is the significant other. Yeah, hopefully you want to run towards your significant other. So let's take a look at our multiplier system. So first of all, when it comes to these horizontal segments, this is really what we care with the identity of solutes, because everything here is permeable to water. And if we're permeable to water, what does the concentration have to be? Thinking about our blood osmolarity. What does the concentration of anything in this upper portion, highlighted in red, have to be? If water can move, the concentrations have to be equal. Got it, Francis. 300 milliosmol. So if we're permeable to water, we cannot have really a change in concentration here. So these horizontal segments are all about changing the composition of the filtrate. And that's why we have secretion and reabsorption primarily at our proximal convoluted tubule, but also under the direction of hormone at our distal convoluted tubule. The vertical segments are what change both the volume and the concentration. So remember, our descending limb is permeable to water. So I'll put a little note here. So we have the descending limb of Henle, descending limb of the loop of Henle. This is permeable to water. We have the ascending limb that is permeable to salt. And then we have the collecting duct, which is really under hormonal control. So let's look at what is happening in this system. So we'll have blood come in, and we'll have some stuff getting filtered. So this light yellow is just going to represent 300 milliosmol. We'll have some secretion, we'll have some reabsorption, absorbing some salt, some water, some glucose, amino acids, some vitamins, reabsorbing all the good stuff. And of course, we'll have some secretion as well, dumping our hunk. And then we're going to start moving down the descending loop of Henle. Now, remember what we had said at close to the very beginning. The descending, as we move down our nephron, the concentration of the interstitial fluid is going to increase. So water is going to move out by osmosis. And you'll notice the filtrate gets concentrated, which I love this diagram because they put the filtrate as yellow, which becomes the urine. So this is going to get more concentrated as the water is reabsorbed. So we often call the descending limb the concentrating limb because it causes our filtrate to get more concentrated. Now, on the other hand, in our ascending limb, we are reabsorbing salt. So what should be happening to the concentration of our filtrate in our ascending limb? What should be happening to our filtrate in our ascending limb if we are reabsorbing salt, both passively and actively? We're pumping it out. What should happen to our concentration? Remember, yeah, it should decrease. Absolutely, Bex, Alex, Nick, you got it. We're decreasing our concentration. So we can think of the ascending limb as the diluting arm. We'll have a little bit more secretion reabsorption at our distal convoluted tubule. And then at the collecting duct, if we have ADH, this increase here is only if we have ADH, we will see a reabsorption of water. And that's why if you are very dehydrated, you have an increase in the osmolarity of your blood, you're going to start releasing ADH. You're going to reabsorb a lot of water, and that's what's going to make your pee a deep yellow. But so far, we only have one guy moving at this point. So far, we just look at one person running in one direction. So you can think of our first guy running in one direction. This is essentially the nephron. But we need the dude running in the opposite direction. And there is a capillary bed that surrounds the nephron. What is the name of that capillary bed? It's one of the portal systems in the body, because we have two capillary beds that are connected. We have the glomerulus, which will surround, we have the glomerulus that will be around our Bowman's capsule, and we have one other capillary bed that surrounds the rest of the nephron. That's why whenever we are secreting and reabsorbing, we're going from the blood to the filtrate, so there has to be a blood source. Oh yeah, Anissa, you got it. That is the vasa recta. And Francis, I'm totally with you. Still love the renal system. It's so cool how it works. So we have the vasa recta. And that's what allows us to establish that concentration gradient, having two things running in opposite directions. We have the nephron in one direction. On the other side, we got the vasa recta. So what happens is that on the ascending limb, we are reabsorbing salt. So salt will come out, it'll get picked up by the vasa recta, and on the other side, by our descending limb, we're going to pull up water. So essentially, as we start reabsorbing salt here, we're able to pick it up into circulation and pull it down. So since we are pulling salt down, we're concentrating, and then to dilute on the other side, we'll pull the water that we're losing from the filtrate by osmosis. So I'll show that animation again because it's pretty cool. Is it gonna play? There it goes. So we have sodium coming out on one end, and we're reabsorbing water on the other end. And one really cool thing about this is the longer the loop of Henle, the greater this concentration gradient will be. So if you think about humans, we have fairly short-ish loops of Henle, and that's why we cannot drink salt water. That actually will dehydrate us because salt water is more concentrated than we can make our urine. We can only drink stuff that is less than 1200 milliosmol. But if you have like camels and kangaroo rats, they're able to concentrate their urine significantly more than we can. And that's why they are able to drink salt water. They have longer loops of Henle. So this countercurrent multiplier system with our loop of Henle is really what allows us to reabsorb a lot of salt and water to conserve water and concentrate the urine. So I have to say, team, absolutely phenomenal work. I know this was a lot of really, challenging but very interesting content. Definitely very high yield for the MCAT. So I'm going to turn it back over to Eli. It was a pleasure working with all of you. Best of luck with all of your MCAT prep. And Eli, it's all you, buddy.
Awesome, awesome. It's always such a pleasure to get to watch Justine teach. Being essentially behind the scenes here has allowed me to really talk with a lot of you and get a little bit of feedback on what you're doing for your prep, and some students who are thinking about taking classes or looking at some options for prep materials has been phenomenal. As far as a couple main just kind of housekeeping points that I saw a bunch of questions about during Justine's session, I do want to point out that the second link up there at the very top of the chat that says the form stack forms, if you fill that out, you do get entered into a drawing tonight for a $50 Target gift card. So I will be picking out the person who gets that out of a random drawing program in about 20 minutes or so. You have to be here to get it, so you don't just get it automatically. We are going to pull that out near the end of our session tonight, just to make sure that you get a little bit of extra bonus and little reward for being here in the first place. The other thing, just kind of some housekeeping, is I saw a lot of students asking, can we chat with you again later? I loved the kidney session. I wanted to learn more about it. I wanted to get more feedback. Like, can I just get resources that are just like practice tests or just access to those MCAT channel sessions, like the kidney, like neuroanatomy, like organic chemistry reactions. And actually that top link, the very top of the chat where it says the You Can Book Me link, if you click on that, you can click on it, and at some point this coming week, if you want, and you find a half hour free that you want to chat with somebody, that is a direct link to us teachers. And you can grab a time with us to talk about, what are the classes we're teaching? What do we feel about certain prep options? Like, what is the plus option versus the normal option? Just to give you a little bit of that kind of real world, honest feedback. You don't have to go through the online website and try and look through all the different options. You can actually get a little bit of more guidance. And actually, as far as the questions I saw, there are a couple big questions I'd like to answer right now, right off the bat. Before we do, though, hit me up down here in chat. I saw a lot of people interacting with our off-cam teachers, but how was the session with Justine? How have your interactions been with our other off-camera instructors who are all MCAT experts in their own rights? And again, remember, you have the option to chat us at any time, so if you want some private chat or you want some feedback with them, you can always continue having those side conversations. Now, actually, of course, awesome, Emmy, great. I love to see the exclamation points on there. If you've got some specific questions that I can answer, toss them down here in chat. I will be able to see them. I will be able to give you that feedback. But I think applause for Justine for the phenomenal kidney session. I will point out another thing. The kidney content that you just saw is part 1 of 2. We actually do a whole second kidney session in MCAT channel where we go back through all of the specific applications of aldosterone, of ADH, vasopressin. What do we have for hormone regulation? How does it affect other organ systems? So awesome. As far as seeing some of that content and really hitting that application, this is the sort of stuff that you need. And I did see Jessica down here mentioning self-paced and making sure that you know sort of what options are available to you for purchase. Obviously, that link that I said is at the very top here to talk with other teachers is essentially like, if you want to think of it as like enrollment counseling. You know that you need something to help you get the success you deserve to have on the MCAT, but you have to put in so much time and so much effort up front. You want to know how to guarantee that conversion, and you want to buy the resource that makes the most sense for you. You don't want to spend money on tutoring if you don't specifically need tutoring, and maybe if you want that class, you want to know which class fits you best. So absolutely, that enrollment counseling is always available, and you can talk with one of us instructors. Now, as far as MCAT score is concerned, I saw a couple great questions during the time when Justine was teaching, and we kind of hit these per person off camera. Some students were saying, well, I took the practice test yesterday and I got a 498. How much could I see a score improvement? How much do I need for the actual test? Hit me up down here in chat. Do you know what score range your schools need, what they claim they need, to matriculate you into their programs? What is the average score range for somebody who gets in to med school? It's kind of going back to this overall big breakdown where AAMC designed the entire test around a 125 per subsection as the average score. So a 500 is this perfect middle ground. You got it. Lizzie Diamond, a 510 is sort of considered to be that cusp range. 510 to 512, as Lacey's putting down here, Megan's putting down here, is sort of that range where we're hitting that top quartile and above. So absolutely your schools that you're thinking about, if you go to the AMCAS distribution where it actually tells you what all of the schools have for averages for each of the different school breakdowns, if you look at the MSAR data, you can actually pull up your specific school and say, oh, this is a mid-tier school, it's a 511. This is a super high-tier school, 514, 515. You can get a better sense of what range you actually need for this test. Just as a quick clarification point, a 500 is exactly there, that midpoint, but that means if you're 500 and below, you are in the bottom half of test takers, unfortunately. And even if you're a little bit above that, you really want to be at that 510 and up just to be competitive and to be considered. A 515 and higher is generally what a lot of students shoot for a higher end school, or to really guarantee their application gets the consideration that they need. So as we're looking down through and thinking about this test, we're always trying to think about what is our stepping stone. Sure, right now you may not be at a 515, you may not be at the top 15% of all test takers, but we can get there. And we can get there in a wide variety of ways. And it's not necessarily the case that you are going to waste time or waste money even to get there. For example, I saw Francis asked a phenomenal question down here in chat. And absolutely, as Aishwarya put down in chat, absolutely, we do have some various discounts. We have some options. There are a couple things that I want to point out about those discounts and about those options you have available. And that is this. In terms of your options for courses in the first place, you'll notice if you go to the website and you try and click through some of the different breakdowns, there's generally a split between plus options and normal options. The plus options, like I put up here on screen, give you that additional bonus of having somebody on hand to actually guide you through the process, guide you through the application, make sure that you're not missing anything, and present the MCAT as part of an entire bundled package. We also have admissions consulting specifically for it, but this is essentially giving you above and beyond what you'd already get, that human interaction, that little bit of extra feedback. And specifically for someone like Jessica, who mentioned down here in chat, trying to maybe do self-paced, self-paced is all on your own. This is the opportunity for you to really focus. If you want to log in at midnight or 2 in the morning and do some practice and do some quizzes, you totally can, but it doesn't give you that live instructor component. If you tack on the plus though, plus gives you that instructor, that gives you that opportunity to really talk with somebody and nail down some options above and beyond the advisor that you have in undergrad or someone you talk to who got in and has a couple tricks. This is giving you that concrete focus that you need. Now, I saw a couple great questions in here about what is that breakdown? What are those different options? Let me be clear about these, because I feel like this is a really big stumbling point for a lot of people, is just understanding who should take which different options. I feel like everybody thinks, well, everybody needs to take a course. If you don't take a course, you're not going to get the same sort of prep. It really depends what you need, how much your scoring is to go up, and how much time you can commit to improving this score, to putting in that grit and that effort up front. So let me break down, depending on who you are, which different option I usually recommend for which different range of student. So let's start off. You are already hitting like a 505 or a 510. You're there pretty close to that cusp. You are basically rocking through practice tests. You're feeling pretty confident already. And what you need, you don't need a teacher to sit down and go through everything with you again. You just want some extra practice. You want to make sure that you have full-length tests. And if you need to go back and do content, you don't want to have to go back to all your old textbooks. You want to be able to specifically, pointedly find the video you need, have it be only MCAT content, not extraneous fluff, study it and move on. You only want to study maybe 100, 150 hours tops over the next couple months. You don't want to be locked into a schedule. You want to do 15 hours on a weekend if you need to. Then you are looking at self-paced. Third option in here on the right. That's your best bet. I'm not going to try and force you into a class because you don't need it. Now, if you were hearing me say all of that and it sounded pretty good, but you said to yourself, yeah, I sort of fit that mold, but I actually need a lot of help in at least one major content area. I feel that way generally, but not in psychology. Or I feel that way generally, but not in organic chemistry. Then your best option would be private tutoring, far right-hand side. And private tutoring, what a lot of people do is they unfortunately start out in one of these two options on the left when they know up front they actually need a whole class in physics that they haven't taken. And they start out in live online, or they start out in person, the two options on the left, which I'll talk about in a second. And then they end up upgrading later, buying 5 extra hours or 10 extra hours of tutoring.
but they've already kind of fallen behind in the course and fallen behind in their studies, and they're using tutoring to kind of play catch up. I always recommend, if you know about yourself up front that you will need some of that additional help, just get it up front. Spend 5 or 10 hours with a private tutor at the beginning of the course or at the beginning of your access, and use that time to make sure that you get up to level before moving further along. The thing that you'll notice about anything that says private tutoring, if you're looking at prices online or looking at options, is that, of course, the private tutoring comes with an entire course. So you get full access, all the resources, all the books mailed to you, everything is included, and a full course with another instructor, and you get private tutoring. So that's why that one always has the highest price tag, because you're building everything into one place in a bundle. Now, speaking of bundle, that is really what I think, for me, was the big selling point for studying for the MCAT in the first place with Kaplan. And it was, I am going to spend, I've talked to some students about this recently, the past couple months, I am going to spend $1,000, $1,500 buying all the books I need, all the practice tests I need, additional quiz bank questions, getting access to high quality videos through some other resource, because I don't want to have to just rely on some YouTube person and hope that it was good enough. I talked to a student who just signed up for one of my classes, and she had already spent about $1,300, $1,400 buying all these other resources when they're all bundled in one place in the Kaplan programs. So for me, it was a no-brainer. Again, for me, in the first place, I considered some other options. I considered some competitors. But at the end of the day, having every single thing in one place, having all the AAMC tests, having all the resources all accessible, was just worth my time, just to buy that up front and save myself time and make sure that I have that high score guarantee and I get that opportunity. Justine, for example, I know, who just taught me that lesson, she was also a Kaplan student as well, studied with us for the MCAT before ending up teaching it. And if that's not a success story, I don't know what is. Now, the other two options here I've kind of held off on, but those two are by far our most common choices that students make. So I'll finish out with these because they're kind of the strongest 2 points. And that is, if you're thinking to yourself, you know what, I like this online interface. I would really love to take more classes, maybe where I have the opportunity to have like multiple different chats that are a little bit more laid out on the screen. Maybe I'd like to be able to raise my hand or give some private feedback or answer questions that are longer or more detailed. Then you are looking at Live Online. You want to come to class, eat a slice of pizza, and still be in your pajamas? Ding, ding, ding. Live Online is your best choice. And we have these laid out based off of East Coast or West Coast timing. So if you want to log in at 3 in the afternoon, okay, fine. Sign up for an East Coast class timing, but show up in your West Coast actual house location and take that session. If that doesn't quite jive with your study plan and you think, that sounds a little bit too loosey-goosey, I would end up skipping those classes, I would end up falling behind on work, I would put something else that's more important to me up front, then you're probably looking at in-person instead. In-person means you go to captis.com/MCAT and you plug in your zip code to the little zip code field that shows up in the upper right-hand corner. That will populate all of the current and upcoming classes that are available close to you. It'll also show you some of the online classes too, so you have some opportunity to think about, oh, is this online class better for me, or is this a better time, for example? But that gives you a live person. You can go and shake their hand after class. You can just look them in the eye and sit down with them before class and have a little conversation. It gives you that maybe a little bit of extra accountability because you're there in an actual classroom, like the vast majority of your classes are in the first place. So I've talked a little bit here. I'm going to pause for a second because I saw a couple good questions in chat that I want to hit. But this often answers a lot of people's questions about self-paced versus plus versus tutoring. So let me leave this up here for a second so you can look through it while I answer a couple awesome questions that I saw come through. One of them, for example, Anthony put down here in chat about 4 or 5 minutes ago about taking the test sort of in mid-June, and it has books and has practice tests, but wants to know like what to do, what to prioritize, how to make sure that this effort you're putting in now pays off in success. So let me start off with a question back to you. How many hours do you think it takes to prep for the MCAT? How many hours does AAMC, the test maker, say is the average number of hours that students prep for before actually sitting for the exam? What do you think it is? Yeah, Sandy, right off the bat, Bex. Yeah, it's the AAMC, the test maker, claims it's about 300 hours on average. And of course, this is self-reported. When you sit down to take the MCAT, it will tell you how many hours a day, how many days a week, blah, blah, blah. Have you been studying? And then it takes that number and gives you a total, right? And that total gets reported to AAMC, and they release that data out as public knowledge. 300 hours. 300 hours is about 3 hours a day for 3 months. It's about 300 hours. So 3 hours a day for 3 months. Now that's the average. You, I'm sure, know somebody in your friend group or peer group who said that, oh, I only studied for a couple weeks and then walked in and took the tests. Or I didn't study at all. I just tried it out once first to see how I would do. So the 300 number is actually an average based off of lower end study times as well. And quite frankly, I don't think you want to be the sort of student who's walking in underprepared and understudied before going into the MCAT. So that 300 is sort of a low baseline that most people think of. And what a couple people put in here, like Levi, like Bex, saying 350, 400, 500, these are actually more like the values we tend to recommend. 300 plus at the very least. And that's 3 hours a day for about 3 months. But of course, if you have a day that you know that you can open up, if you can take some additional time on the weekends, I tend to see a lot of students who put in 8 to 10 hours on Saturday, Sunday alone, just to really push that time a little bit more condensed and get all of their studying done in about 8 to 10 weeks instead. I really recommend efficiency, effectively studying. You don't want to be putting extra time into this MCAT if you can help it. It's an opportunity, yes, but we want to get that score conversion, get that high top 25% tier, and then move on with our lives. Get into the application cycle, get that primaries done, get secondaries back in, go to the interviews, and actually start the process. So as far as other questions that I saw a really good question about some feedback from this section, and also for those of you who came to the practice test that I gave yesterday, I saw a couple good questions about taking more practice tests and how to use that information. I would say 2 things about that. One, in order for you to get a good gauge of what you need to do from this point forward, I tell this to all my students, is you need what this says at the top of the slide, realistic practice. And that is, of course, why we have all of the full-length tests included in the Kaplan courses, whether you take self-paced or whether you do a whole course. And we have every AAMC test and practice material. So if tomorrow the test maker released 4 new full-length exams and a small handbook of resources for you to use to study, we would buy those immediately, plug them into your courses, and you would have them right away. Right? That's the beauty of this, is you never have to feel like, oh, should I go buy this other person's additional practice quests? Should I buy this other group's question set that they claim is a good bonus practice set? No, we never have to worry about that. And even the 14 full-length tests, we generally recommend at least 5 full-length tests to prep you for the actual exam, the endurance, the strategy, the time management, essentially, to get through it. But if you want to take 10, if you want to take all 15 that are available, awesome. That just shows you have that additional higher level of commitment to hitting that top 25% or top 10% or top 5% score range that is really going to guarantee that schools take your application seriously. That's one thing that I always say. Realistic practice is the thing you need to guarantee that you know how you will perform on the actual test. The other thing is something like this. That is your personalized SMART report detail breakdown. So there was a great question that came through here from MGV527 who said, I would love to read the books before. I would love to make sure I have that foundation content before I even get into the course in order to hit my maximum potential. Oh my goodness, I wish every single student said that before coming into our classes. But there's 2 responses to that feed back into the SMART reports that you're seeing up here on screen. And that's number one, absolutely, 100%. I would love it if every single person who came into the Kaplan course was 100% accuracy on the foundation knowledge and the content review before starting the classes. I would love it because that's really a great starting point for the course. And that's honestly what we generally recommend. The first third or so of the Kaplan course is really just spend your time focusing on content, focusing on foundations, making sure you've got that baseline. Now, the second thing I would say in response is after that baseline of content, you want to know how you actually perform on the real test. Because I'm sure those of you who've done some practice questions or done the free practice tests that we offer at Kaplan have noticed that there are some questions that you totally know the content of. You'd be able to talk to somebody at a dinner party about it. You could raise your hand and answer it in class, but the way that it was phrased or the way the wrong answers were written made you think that two answers could be possible. Now, of course, I have to say that is not the way the test is designed. There is always one right answer, and there is always one rotten answer. And we have to figure out what that is. What about the right answer matches to what the AAMC gave you for a clue? What about the wrong answer was designed to tempt a student just like you? But how does it fall into a classic wrong answer pathology that we can recognize and ignore in the future, feeling motivated, confident, satisfied that we have chosen the right one along the way? So what a lot of people unfortunately find is that they get bogged down in the specifics, or they get behind on certain content areas, and they're flustered and they're getting through the flashcards just barely. But that one content area may not be a make or break on your score. And again, that rolls back into the slide that I've left up here on screen for a few seconds. This is what we build into every single course, our adaptive feedback engine. That adaptive feedback engine is an opportunity for us to give you that guidance that you would get one-on-one. That, hey, here's how you're doing overall in this test. But then within this one content area, here's how you're performing. Even more granular than that, within this content area, here are the question styles that you're missing. So it might not be what you're freaking out about. It might not actually be, oh, I don't have full confidence in this content area. I'll go back and reread. I'll go back and restudy. It may be that the question style or the wrong answer type is what's actually causing this deficit. And as you go through with the adaptive learning engine, with the smart reports technology behind the scenes, it'll tell you, what have you actually missed? You would not believe the number of students who unfortunately get feedback from a full-length test or get feedback from a quiz and say, palm the forehead. Okay, I guess I got to do more flashcards. I have to go back and do more reading. Not necessarily the case. And yes, you could totally purchase an additional tutoring package. If you need help with your applications, you could purchase our admissions counseling. Kaplan offers admissions counseling for writing personal statements and building out your application stronger. But for tests, for giving you feedback on just what you need today for the next 5 hours of studying or the next 10 hours of studying, this is it already built in and automated. And again, that's one of the beautiful things of any Kaplan course that you buy. You always get this. You always get the books. You always get all the online videos. You always get all of the full-length tests. It's just not something you have to sit there and piecemeal find bit by bit and do some sort of maker prep just to get the resources you need to ace this test. Now, at this point, there was another great question that came through, and it was really about the high score guarantee. I love the private questions that have been coming through here. I know that a lot of our off-camera instructors have already answered a ton of great questions. I thought Justine jumping in and answering some questions. Of course, I'm sure you've chatted with Mary and Mike and Nikolai. And if you haven't had a chance, reach out to them, because I know they're right now guiding, it looks like about 15 or 20 people through different options. A handful of people who are actively signing up for classes right now. That is awesome. I love to see that. But no matter what, whether you're already signing up or not, this up here on screen, this is something that a lot of people unfortunately don't know the full extent of. First up, If you are considering something for prep, whether it's a competitor, whether it's just buying full-length tests, whether it's buying books online, I really hope that no matter what, you have a high score guarantee somewhere in that, because honestly, you deserve that. The amount of money that you are putting into this, the amount of money that you will spend on just applications, just on interviews, you deserve to have the highest score possible to give you the best chance of getting into that medical school and becoming the physician that you're shooting for. So yes, we have a high score guarantee, but honestly, I feel like that's low-hanging fruit. Any of our competitors who don't have a high score guarantee are missing out on what I think is the easiest thing to offer. Now, let me follow that up with the fact that we don't give out money back because our classes are just too successful. So what we actually did is we went one step further. Because everybody was improving in their scores, because everybody was going up from whatever the baseline score they came in with or the diagnostic score that they took coming into the course, we added 2 more features to the high score guarantee just to make sure that you actually could see that that sort of money back feeling, essentially. So there's 2 pieces that you're not going to find really anywhere easily, but you'll see occasionally this referenced. Retake the class for free. What you have to do is just this. Take the class. Your score went up. I had a student who just did this, actually. He came in with a 494, right? 30th, 40th percentile range. Super low on the spectrum, so he had a lot of room to move. But he came into my class 494, and he went up to a 504. So a 10-point jump. I mean, literally a jump past about 30% of every other test taker. Huge jump for him. 10-point improvement in the course that he took with me. But he came at the end of the course and he said, listen, I had some family things come up. I was really busy at work. I didn't feel like, even though I jumped a lot, I didn't feel like I really showed myself to my full potential on the actual test. What can I do? And I said, Nate, you get a free repeat. It's built into every course. All you have to do is call 1-800-CAP-TEST and say, I'm not satisfied with my improvement. That's it. I'm not satisfied. Sign me up for a new class. So he ended up taking a class, again, with a colleague of mine, Kristen Russell, who's a phenomenal teacher. You'll see her a couple times this week. I think she's hosting another event tomorrow or the next day. Phenomenal teacher. He took it with her and he went up 8 more points. So not as much as with me, I like to tell her, but 8 more points. He went up to a 512. Boom, he's right there in that top quartile. He's well within reach of even top tier schools with that score. And every school that's going to see that MCAT score is going to take him seriously as an applicant. So overall, he went up 18 net points from the beginning of the Kaplan journey to the end of the Kaplan journey. And it's because he had that free repeat built in. And again, I just love that story. And I love that he is now in medical school and he's actively living out that dream of becoming a physician. So it's not really a question of, do you care enough? It's a question of how much are you willing to put in as far as time, energy, finances to find a way to get into that, that prep option that gives you all the resources you need. And that comes back full circle to the last 2 points I have to do, because we're like 5 or 10 minutes out from that hour mark, and that is give away that Target $50 gift card. The other thing is remind you about the opportunity that you have for things like tuition assistance, breaking up the classes into payments. We give military discount for military veterans or family of military veterans. We have some discounts for prior students. If you took the SAT or the ACT with us, no matter what, if you are actively planning on taking a class or tutoring, or you're thinking about doing one of those self-prep options, really get that guidance to make sure you get that discount. If you're, for example, an AMSA member, if you have, if you're part of the board, like you're the president of your AMSA group or chapter, we can give you additional discounts. So I don't want anybody to feel like you're walking away from our session tonight not knowing where to turn or who to talk to. Use that top link on that chat where it says you can book me. Reach out to one of us. No matter what, we will be able to give you something towards a discount, towards money off, $200, $300, no matter what. Maybe a bigger discount depending on your school, or if we have a contract with them, or if you have that ANSA membership. again, I'm a teacher. This is what I do. I just want to make sure that you get the best guidance from me and the best opportunity to improve. Now, last thing I do want to do before I give you some final words of wisdom is mention that randomly selected, we do have a winner for that $50 Target gift card that we held out till the end tonight. Elizabeth De Loretto, you have been selected in today's drawing. So Elizabeth, if you're still here, because you don't get it if you're not here, if you're still here, reach out to us privately, let us know, and we will get that $50 Target gift card transferred over to you. Congratulations. And really, let me just say for everybody, congratulations for coming tonight. Congratulations for taking time out of your weekday evening after work or school or volunteer or lab or classes to be here, to put some time towards improving your content knowledge, improving that foundation, improving your ability to understand the MCAT and figure out tools and strategies and success, and really for having that grit. The students that we see come to a lot of these events, whether they are immediately future students of ours who jump into classes or later students who are using resources, no matter what, the students who come to these tend to be some of our highest performers at the end of the day. We love seeing you in these events, and we would love to have you for students, but no matter what, let me just end our session tonight with congratulations again. Congratulations for being here. If there's anything else that I or the other off-camera experts can do to help you on your journey or help you towards better decisions or options for prep or just give some guidance, do not hesitate to let us know. So with that, have a great rest of your evening. We hope you attend some more of our free MCAT sessions this entire week, and I hope to see you more down the line. Take care.